You're watching PowerNation. After we ran our twin big block setup in the dyno cell, we said it, and a lot of you said it as well. Why don't we try phasing the engines different to see what it does?
Today, we make it happen.
Plus, they're making big power down in Houston at Samtech. We're gonna check it out. I don't think the pipe length off the back is a concern as long as we don't contaminate the room.
Yeah, I think if we just cut it right in front of the Y, I think we have enough tubing to make it go all the way to the back, and I think it'll keep it pretty clean in here. I think it'll work.
I like it. Hey everyone, welcome to Engine Power. Today we are getting back on our favorite and probably the craziest thing that we've done in this shop in a while. If you're not familiar with what you are looking at, these are two 496 cubic inch big block Chevys, and they are hooked together and have been ran on the same dyno at the same time. Now, if you are not familiar with this project and want to know how we've done this and actually made it work, check this out. Relatively speaking, building the engines was the easy part. After dyno testing them separately, we added their total horsepower and torque numbers, which was the target we aimed for when running the two big blocks together.
Next, we fabbed up a drive line to connect the two power plants using a 31 spline axle shaft. We made some aluminum spacers to keep the two dyno carts firmly in place and made some adjustments to the coolant and fuel system to accommodate the dual setup.
On the dyno, our twin big blocks made 1,167 horsepower and 1,204 pound-feet of torque, which was within 4% of our expected result. Solid.
Now that we have a coupling system that we know will work and handle the power, we can never leave well enough alone, and today we are going to make some changes to hopefully improve power and most definitely learn something. The first thing we're going to try is splitting the exhaust system. For packaging purposes, when we built the system, we had both engines Y into one piece of 5-inch, and that could be a restriction, so we're going to split those, make them independent, and that could hurt power, could help power, but there's only one way to find out. The second thing we're going to do is actually change the phasing of the engines, but we'll get to that later and explain how we're going to do that. For now, let's get started on the exhaust. After removing our exhaust, we'll start by cutting off the Y connection. We'll add an extension to the rear engine and reinstall our S-pipe for the front engine. This allows us to slide on some 4-inch flexible exhaust tubing, which extends to the exhaust plenum.
I'm not gonna lie, this does make me a tad bit edgy. Now it's just a regular dyno session,
yeah,
only with two engines, and some drive system that you welded.
I'm only kind of worried now. Did it do something?
I don't know.
I thought I saw maybe, but...
Okay, well, okay, so we have a little more torque.
Yeah.
1,217 pound-feet and 1144 for horse. Now,
which is actually down.
The horse is down by a little bit. It made 1167 before.
Overlay that with the last one we did.
Okay, it's trading off back and forth. Made the pole fine.
Yeah. I say it ran just the same, so.
Carburetors look fine.
Let's back it up, see what it does.
Double engine exhaust mod, take 2.
Yeah, see if it prints the same numbers.
Maybe just need a little heat in it.
Yeah, get some more oil temp in it, I guess.
Okay.
Okay, yeah.
Yeah.
Wow.
A little more consistent. Notice how the graph is like
super smooth,
super
right?
happy. Yeah, and we'll take it. 1162. I mean,
that's pretty close to the 1167 that we had before.
Definitely up on torque.
Yeah, I think that's a
twice.
solid. Yes, twice and 8 pound-feet with some good oil temp in it. So.
Yeah.
Wow.
The graph looks better.
I would call the exhaust splitting a success.
Me too.
Is it a dramatic change?
No.
But I would say that is a good success.
I would say that the graph looks better.
Up next, the search for more power continues as we phase the engine.
Plus, we meet the latest generation of high-performance engine builders at Samtech. We are going to continue doing some testing on our dual big block dyno setup, and so far it's yielded some interesting results. We have split the exhaust into two separate systems, and it was pretty promising. So we are going to continue on by phasing the engines different, meaning we're going to change where they fire relative to each other. Our drive coupling system that we have created was specifically designed to make this an easy task, and so far it's held up pretty well. So we are going to continue on. In their current configuration, both engines fire the same cylinder at the same time. This means that when engine A fires the number 1 cylinder, engine B is also firing the number 1 cylinder, and this continues throughout the firing order.
We are going to rephase the engines to be offset as close to 45 degrees of crankshaft angle as we can get. This means that cylinder 1 of engine A will fire, and then 45 degrees later, cylinder 1 of engine B will fire. Engine A cylinder number 8 will follow, and then cylinder 8 of engine B, and so on. This essentially recreates how a V16 works and hopefully will show a difference in power.
We'll start by putting both engines at 45 degrees before top dead center on the number 1 cylinder. Then we can disconnect the drive axle from the harmonic balancer.
So much easier to turn over now.
Where there's only one engine. Next, the front engine is rotated to true TDC, and now all we have to do is rotate our axle until the bolts and splines line back up. Since it's been disconnected, the drive axle is dialed back in for runout.
I'm interested to see if it changes the way it starts, because
I hope so.
Before we had, two cylinders trying to be compressed at the same time, and it was a little hard on one single starter. So maybe it'll be better this time.
It needs all the help it can get.
That's
so,
for sure.
Let's see if we can get her lit here. That is better.
That's better.
That is better.
Definitely better.
It sounds
a little different, yeah. It's hard to hear, but it definitely sounds a little bit different.
Oh, it definitely sounds different. Theoretically, if it makes power, it makes more power. Say it all of a sudden makes, 1,260 pound-feet and 1,200 horsepower. I'm going to say I planned that and I knew that was going to happen, but that will be a complete lie.
If it does, I will be pleasantly surprised. And will we be able to logic it out? Yes. But if it doesn't, will I be surprised? No.
I am literally going to say I meant to do that.
Sure. Okay.
That is an improvement.
That is big.
1,229 pound-feet of torque. Well, look at the horsepower, 1,183.4.
Wow.
Now, if they were dead on, it'd be 1,200.
Yeah.
That is extremely close.
That is close. Overlay that with the old one, because that's peak numbers. But I'm willing to bet that it's probably everywhere. To be that big of a spread.
I'm sure it's up everywhere.
That is, wow.
Let's make another one on it just to say we did, because we made 2 on the first one.
Yep, back it up.
Maybe with the heat and all that stuff. All right.
Try her again.
$1,232, and it's a power's down 1179.5.
Yeah, just down a few.
Just down a few, but
wow.
Wow, that told us something right there. Okay.
That is interesting, right?
So that's 10 to 12 pound-feet.
So we're not making more horsepower,
no.
But somehow phasing the engines has freed up horsepower in terms of pumping losses between both engines. Not even stop with the phasing. We're like, right now we're at 45, but well, what if you're at 15? What if you're at 30? What if you're 180 out?
What if you're 180 on the opposite? Yeah. There's so many things.
So many options or things that we could try.
That is
That's crazy
this
right?
was one of the most interesting things I think I have ever done. I've done lots of R&D in my career.
Same.
One thing I've never done is had two engines at the same time hooked together.
I still can't believe that what we built works. At first I was really sketched out with it, because I had to weld it. But now we've made several dyno pulls on it. I feel really comfortable with it. Now I just want to try more stuff,
Now we want to try more stuff. Well, that is going to be left for another time. But as for now,
still, great success.
Happy times. Up next, from old school naturally aspirated power to the latest EFI and CNC technology, you'll find the knowledge you need at Samtech.
We've made our way out of the shop all the way down to Houston, Texas, to the School of Automotive Machinists and Technology, or as you may better know it, Samtech.
If you want to be a professional engine builder, work for a race team, or even start your own shop, this is a place to be to get your education. Since opening its doors in 1985, Samtech continues its mission, providing the knowledge and the experience students need to become successful automotive machinists. Here, students just don't learn in the classroom. The entire campus is a gearheads laboratory, where you can master the art of EFI calibration using an 800 horsepower supercharged Ford Mustang, discover how to make big power in the dyno cell, train for a career in CNC machining, and even work on the school's NHRA race team.
Programs include engine block machining and cylinder head machining, along with EFI calibration and CNC machining. Samtech also offers the Associate of Applied Science degree, which helps graduates seeking to advance their career at larger corporations, which often require an associate degree.
Of those courses, you can take as many or as few as you want, but most of our students end up taking at least 2, mostly 3 or 4 courses, just to be well-rounded. You're going to start in our orientation program and you're going to work on the math associated with compression ratios and things like that, how to take measurements properly. And then you're going to go into the theory portion of our course. After the theory portion, you're going to be hands-on in the lab for about 1/3 of the time that you're here. And that hands-on experience is really where you're going to be working on your own projects, working on the school's projects, and working on all the machines.
For many students, it all starts with the engine block machining program.
The way that we teach it is it's all an air pump. It doesn't matter what application you're using it for, you're going to learn the fundamentals of how to make horsepower, how to make more torque.
Students learn foundational skills, such as degreeing the cam, measuring main bearing clearance, resizing connecting rods, decking the block, as well as both cylinder and align honing. With a student-teacher ratio of 20:1 or less in the laboratory classes, instructors have the time to make sure every student gets the attention they need to understand the coursework and the hands-on experience necessary to drive those technical concepts home.
We want to go and be able to have an experience where we're able to carry on learning, but they're also able to ask a question and we'll be able to answer it relatively quickly and still be able to move in a very fluid, dynamic way.
You'll learn machining on state-of-the-art automated equipment, but you'll also learn how to do things the old school way on manually operated equipment.
We still have a lot of old manual machines. It's not just about the high-tech stuff. Every shop, if you don't have the fundamentals, you can't dive in and go on to some of the newer equipment. When we upgraded our equipment, we sat down with some of our employers and we said, what do our students need to be learning on? They gave us a list and that's why we picked the machines that we did, but they told us specifically, don't get rid of anything that you have. You still have to learn on all that. You've got to, crawl before you can walk, before you can run kind of thing.
Ultimately, the engine is a high-powered, complex air pump, and for most applications, the goal is finding maximum airflow. With that in mind, the cylinder head program teaches the science and dispels the myths surrounding cylinder heads. Students learn to port cylinder heads, then check the results on the flow bench. A good valve job ensures a tight seal and optimal airflow in the cylinder head. With guidance from their instructor, students learn to set up the machine, take turns cutting the valve seats, and then check their work with marking fluid. Finally, they check seat height, making sure it's consistent from valve to valve.
Throughout the day, we constantly notice students stopping to help each other with the coursework, but they also share a strong sense of friendly competition.
they always want to go and have competitions and push each other. And so at the end of the day with that, I encourage competition. That's why I ended up setting up both of those degree wheels right next to one another. Is so that way then they can look over at their friend and see that they're doing it just a slight bit faster. And so that way they want to push a little bit harder to move a little bit quicker.
Instructor Andrew Hackmeister can relate to his students. A few years ago, he faced the same career decisions they did and decided to study at Samtech.
Whenever I was first growing up and about ready to graduate from high school, I was actually still focused on being a welder in the oil field and being a farmer. And well, whenever I was finishing up my welding school, the oil field kind of took a crash and I didn't really know what I was going to do, and my brother suggested that if I were to do anything, I would come here. And sure enough, that's how I actually ended up here.
Now he's teaching a new generation of students.
The most gratifying thing is when you walk over and see a student that's struggling, and you know that he knows what he should be doing, but he's just missing the one step that's, to complete the rest of everything. And when you walk over and you kind of give him a couple of little hints, and you see him come up with this aha moment all by himself. You got 99. Perfect, good job.
Up next, to get ahead, you've got to stay ahead of the latest automotive technology. These days, people may say they can learn anything they need to know online. There's no question that you can find plenty of information on the internet, but to really understand engine machining and advanced technology, there is no substitute for hands-on experience.
You can't bore and hone on the internet. It's that simple. You can't balance, you can't run a dyno, so you need to be here in person.
One of the most rapidly expanding fields of technology is CNC, or computer numeric control. CNC machines are programmed using languages such as G-code. Once that program is run, the machine performs all required cutting, milling, and drilling automatically. Advantages of CNC include increased production speed, along with more precise and consistent machining. At Samtech, students aren't just button pushers. They learn how to make accurate measurements, use CAD and G-code to create programs, and set up the machine for accurate and safe operation.
And that's why we teach G-code, because G-code is what runs the machines. So we want those fundamentals. We want them to be able to measure parts. We want them to do more than just push a button and hit go. So we want them to be able to set up the machine. We want them to be able to program the machine, run it, get everything done from start to end. We can build literally anything inside these machines. We're an automotive-focused school, so obviously we do more automotive work, but we have students all over in different fields. We have students in oil field, aerospace, medical, defense, you name it, somebody's there.
Some of our recent graduates have gone on to work for SpaceX and Blue Origin.
CNC technology is also the foundation of 3D printing, which adds material to create an object instead of removing material like a traditional machining process. Electronic fuel injection provides incredible control over how an engine runs. Using a computer or a handheld programmer, the pulse width of the fuel injectors can be precisely adjusted to dial in the desired air-fuel ratio across the full RPM range. It sounds complex because it is, but Samtech's EFI calibration program teaches students how to make any EFI engine run its best for any application. Students study the science behind EFI, giving them tools to dial in the power, drivability, and efficiency of their engine across its operating range. Then they get hands-on experience, setting up engines to operate smoothly on the run stand. By using the chassis dyno and the engine dyno, classmates gather in-depth information about the results of their calibration work.
Maybe you're wondering if you've got what it takes to succeed at Samtech. One of the qualifications for admissions is passing the Bennett Mechanical Comprehension Test.
It was brought out by the government to see who to put in the motor pools, in the armed forces. It really does work, there's no doubt.
You can take the test online to get a better idea of your mechanical aptitude.
But if you come in here with an open mind, you pass the Bennett Mechanical Aptitude Test and you apply yourself, you're going to learn how to work, okay? That's the kind of people we want, you know what I'm saying? They're ready to learn.
In addition to in-depth knowledge of engine building and automotive technology, students at Samtech are prepared to succeed in the world of business.
We have a job placement rate in the 90% because we're not just training somebody how to do the machining, we're training them how to be a professional, how to work together with other students, share machines, be able to share tools, all of that. We're very fortunate to have more employers calling us than we do graduates. So we are able to find not just any job out there, but the job that you want.
Samtech maintains a close relationship with leaders in the automotive industry. Those leaders understand that it is crucial to educate new generations of technicians. Seafoam has provided scholarship funds to assist students at Samtech in fulfilling their dreams. All right, guys, I have something very special for you. On behalf of Seafoam, I'd like to present you with this check for $20,000 to be used for scholarship funds.
Seafoam, thank you very much. This is going to make a difference in the lives of our students. We really appreciate it, and so do they.
There's a world of possibilities for engine builders and machinists. Samtech is ready to help you find what you're looking for.
Come take a tour of the school. If you're thinking about coming to Samtech, do your research, make sure that it's right for you, but the biggest way to do that is to come take a tour. See what we do on a day-to-day basis. You're allowed to sit in on a class. You know, we have parents and students do that all the time. Come see for yourself.
For more information on anything you've seen today, please check out our website.